Hi there everyone, I'm Mayur Gohil. Welcome to the video lecture series on double integration. Let us continue our discussion with double integration topic with this word problem. This problem is telling us to sketch the region of the integration and evaluate the double integral over the region S. E to the power x plus y is the function and the order is not given and it's set over here as ds, where S is given by the set x comma y such that mod of x plus mod of y is less than or equal to 1. Now, very important thing regarding this question is going to be this region which is given by this set theoretical notation. Okay, this is one of the most important mathematical way of giving the regions, and it's slightly trickier for a new beginner or a person who is seeing this for the first time. So let us understand this carefully. So the set which is given to us is the set of all the points x comma y such that mod of x plus mod of y is less than or equal to 1. So here what we have to understand is this condition mod of x plus mod of y that is less than or equal to 1. Okay, so let us try to understand first of all here. Suppose if I put x and y together 0, so that means this equality is satisfied, and so you will have 0 which is less than or equal to 1 over here. Okay, that's gonna work. Further, when I try to say that the points which are there over here, if I say x is 0 and y is some another number, if I put x equals to 0, okay, if x is equal to 0, then I have mod of y is less than or equal to 1. It means that the value of y for me is always going to lie between -1 and 1. Alright, further, so on the range of y it is going to be between -1 to 1. Okay, similarly the notion goes for x also. If I put put y equals to 0, if you put y equals to 0, okay, what's going to happen about x? You will have mod of x less than or equal to 1, which will imply again that -1 is less than or equal to x less than or equal to 1. Okay, so this kind, so at least you can get some rough figure about your diagram. Now that is where the endpoints are gonna lie. That's how you will get this. But further details, if you understand this, I'll give you the hint here that this condition is comprising 4 equations in front of you, rather 4 inequalities over here. That is, first one is x plus y is less than or equal to 1. Second one, you can say that is minus of x plus y is less than or equal to 1. The third one is minus of x minus of y less than 1, and the fourth one is this, x minus y is less than or equal to 1. Okay, so we need to plot this 4 inequalities on the diagram and try to understand what happens on the xy plane. So let us see how to go about it. So you have your xy plane here, okay, and then you plot, as you now know that origin is there inside the set. Okay, origin satisfies, so origin is going to be included. Moreover, you know that y is also going to be between -1 and 1, and x is going to be between -1 and 1, so you can plot these 4 points. Now with the definition of mod, we know that mod comprises of positive as well as the negative values of the particular given variable. Alright, so you have to take both the cases. So when x is positive, x is negative, both cases you take, and y is positive, y is negative, both cases. So 2 into 2, 4 cases you will have, so 4 inequalities you have in front of you. Okay, so once you draw the first line, okay, x plus y is equal to 1 you draw, but now then there is this less than inequality there. So less than inequality, you plug in 0 comma 0. Okay, so when you plug in x and y as 0 and 0, you see that the inequality is satisfied. That means the region that you need to shade is towards the origin. I hope those of you who have done the LPP, linear programming problems, you are aware that which side of the region to be shaded. Here I give you the hint that whenever you put the origin in the equation and the inequality is satisfied, okay, so then the region towards the origin is to be shaded. Okay, now so further, when I go for the second line, that is minus x plus y is less than or equal to 1, so I'll remove the inequality sign and just put the equal sign, so to draw the line, and then I have to take the region towards the origin again over here. So it is this region which is common, I can see. Okay, now the next one, when I go for the third equation, it will be here. Okay, so again the region towards the origin will be shaded. Okay, here like this. Now finally when you go for the fourth line, again the region towards the origin is shaded. Okay, now the common region to all the four lines is the one, the square that you can see, the diamond kind of square over here. Okay, so I'll just erase the all markings that I have done here. Okay, and shade that region with this green color. So this is the shaded region which is required, and it is the region S that they are calling. Okay, so this is the region S1 and S2. I'll label this 4 vertices also. Okay, so it will be easy for us to understand which region is S1 and S2. So S1 over here, just a minute, S1 region is the region A, B, C, O, A. Alright, that is the region. So region S1 is A, B, C, O, A, and the region S2 is D, A, O, C, D. Okay, it's the triangle which is to the right of the y-axis is the S2, and that is to the left of the y-axis is the S1. Okay, so those are the two regions. It's very much clear right now. Now we have to write the integral for the triangle S1. Okay, the region that you can see ABCOA. ABCOA. For that triangle we have to write the double integral. So what you do is you draw a vertical line. Okay, so the moment you draw the vertical line, you can see that it is entering over here. Now the line is BC. Okay, the BC is the line, and the equation over here is minus of x minus of y equals to 1. Okay, so the entry point is going to be y equals to, okay, let me write down here, it's going to be y equal to minus of x minus of 1 is the entry point. So the lower limit of the innermost integral is going to be that, and for the exit point is the blue dot. The blue dot is on the line minus of x plus y equals to 1. So the exit point, the uppermost or the the upper limit for the innermost integral is going to be y equals to 1 plus x. Okay, and we can see that the projection is from -1 to origin, hence the what we call the integral I1, okay, which is for the region S1, is going to be this. Okay, yeah, you can see here the integral written here. Okay, now same way we write for S2 region. Okay, for S2 region DAOCD, as you can see, the line is entering at the this yellow dot over here, and the line is x minus y equals to 1. So if I simplify this line here, it's gonna give me x minus 1 is equals to y. Okay, and the exit point is this purple, the purple pink dot that you can see here. It's going to be y equals to 1 minus x, right? 1 minus x, that's the line that we are gonna have. So that's the equation over there. So the projection over here you can see is from origin to your point D. So origin to point 1 comma 0, so the projection is from 0 to 1. Okay, OD is the projection, right? So you will have over here your answer as the following double integral. Okay, this is the double integral you'll have. So the lower limit for the innermost integral is x minus 1, you can see over here, and the upper limit is 1 minus x, and the projection is from 0 to 1. So dy dx order we have established. We have found I1 and I2. Now we simplify them as per the regular method, but the total integral that we need, the final answer for the given region, is going to be I equals to I1 plus I2. It's gonna be the addition of I1 and I2. So let us calculate that. And yeah, you can see here this small animation that I have tried here to show that this is how the two region I'm visualizing right now. Okay, so that's why the entry point and the exit point that you can see, yeah, that's the animation I'll try over here to help you to understand that the two triangles are in this manner that we are observing right now for dy dx order, or type 1 region. Okay, so this region is type 1 right now for us. It can be type 2 also. I'll explain you in a moment. Let us first complete the solving part of this. So I1 and I2 are the two components of the main answer that we have to find. So let us solve for I1. Okay, so for I1 what do we get is this. Okay, so I do the laws of indices over the function. So e to the power x, e to the power y. So integrate e to the power y, you will get the following answer. And once you simplify the function by multiplying e to the power x inside, you will get e to the power 1 plus 2x minus e to the power minus 1. And the only variable now under consideration is x. So you now integrate with respect to x. This is definite integral. It's very straightforward from the school level. So once we integrate, we obtain here our answer as I1 equals to e to the power e divided by 2 minus 3 upon 2 times e to the power minus 1. Okay, so this is our first answer for I1. Okay, now let us go for I2. When you consider the I2 and simplify in the similar manner, you obtain I2 in terms of the single variable x. Okay, so the variable over here is x, and the function that becomes is e minus e to the power 2x minus 1, and we are integrating over 0 to 1. So again, it's a definite integral and single variable, so we know it from our high school level. So we complete this integration and we obtain I2 as e divided by 2 plus e to the power minus 1 divided by 2. Okay, having got this, we now add the two, I1 and I2. On addition of I1 and I2, what do we obtain? Our final answer as I equal to e minus e to the power minus 1. This is our final answer for I. Now this is very non-trivial answer. Okay, let me tell you, because most of the time we are very much used to get some nice simple answer. Now this is in terms of the irrational number e. So I chose this example for this kind of non-trivial answer basically. So I hope you like this example. So this is the procedure for this. Now, as I told you that this question can be seen as type 2 region also, so let me take you to that. This same region can be seen in another way round. We saw S1 and S2. Instead of that, some student can be having another vision, and he might try to see that as R1 and R2. So the region above the x-axis is gonna be called as R1, and the region below the x-axis is gonna be called as R2. Alright, so over here when you do for the region R1, it will be considered as DABOD, and this is the integral that you will get as for the order dx dy. Okay, so the here the lower limit is y minus 1 and the upper limit goes as 1 minus y, and the projection over here on y-axis is from 0 to 1 first, and for I2 is minus 1 to 0 is the projection, and the lower limits are for minus y minus 1 up to 1 plus y, okay, for the variable x. Okay, so the order is dx dy in this case, and the answer still remains the same. So the two ways both the answers can be solved and you can get the same answer, but approach is different, vision is different, thought process is different in both of the answers, but almost parallel. Okay, so this was the example that I wanted to deal. This is one of the very important example according to me if you are intending to do little depth kind of questions in double integration. This is one of those. So till then, I hope you like this content and you enjoyed the problem. I know it was slightly difficult and slightly unusual for you to see this, but yes, this is one of those, and I hope you like this entire example and the content, and please hit like button and share it with your friends and family members, those who ever are interested in double integration. Please subscribe to my channel and hit the bell button over there. Okay, thank you. Till then, keep solving good amount of mathematics. We shall soon meet in another video lecture.